Hello, my name is Doug Beatty, and I'm from Fivetran and DBT Labs. We were separate companies 1 year ago, and now we're merged and we're together. Today, I'm going to talk with you about supernormal data architecture. This is the intersection of design and software, and also uh, our product, DBT, and DataFusion. And I'm going to talk a little bit about the history of DBT, what it solves, and where it's now going, and how data fusion fits in. To get to the design part, first I have to tell you a little about my personal life. I spend a fair amount of time on the treadmill, or as many people call it, the dread mill. And what I do to help this time be more enjoyable and meaningful, I just put on YouTube and I find great content to watch. And one new channel I've been consuming lately, it's called Design Docs. And they're short documentaries where they talk about different designers, design histories, and they do a deep dive on those designers and their philosophies. And so today I'm going to talk about one of these design docs, which is supernormal, some of the characteristics of what makes something supernormal and how that relates to the design of DBT and data fusion. So in this documentary, they talked about this art show where these artists, Fukusawa and Morrison, they made a collection of objects from everyday life that they thought were not just everyday objects in a boring sense, but everyday objects that were so good that they belonged in an art show. So they collected over 200 of these objects and, numbered them and placed them. This included chairs, bicycles. I think this is a coffee maker. Some of you may have owned this coffee maker at some point. And they put them in the art show, and they also compiled them into a book, subtitled Sensations of the Ordinary, and use these objects to explain what made them special, more than just ordinary. And this inspired me to start thinking of my everyday life, which includes data and software, and look for some of those same characteristics. They had a lot of characteristics, dozens and dozens, and I just picked out a few that kind of spoke most to me. The key overarching idea is that super normal objects or software, they perform an ordinary job, but they do it in an extraordinary, exceptional way. One way they do this is they become a part of your everyday life through your usage of it. So when you're using CoreLogix every day as part of the way you do your work, that becomes super normal through its everyday use. It also will fit in well, rather than being a square peg in a round hole, it's going to fit in with its context. It's not flashy. Supernormal objects favor having utility rather than pretty feathers. As a result, they're often not noticed. So you actually have to tune your eyes to see these things because they'll blend in so much that you won't notice them. And they tend to be something that you realize how great they are over time. because it sticks with you over time. It's reliable and trustworthy over time. Okay, now that we've introduced supernormal, let's talk about DBT a little bit. How many of you have heard of the software product DBT? Okay, I just did my count real quick, and I think I got a count of 5. My little query engine, that's what it came up with. So that's maybe a little bit less than half of us. So I will do my best to explain briefly the key problem that we're trying to solve, and then I'll tell you a little bit about how DBT does that. First, I'll tell you like what the initials initially stood for. It's data build tool, and it's to build data pipelines. Okay, so I had a job where I was the head of data at a university, and we had dashboards that we wanted to present to people with key business metrics. One problem that we ran into is something that like basically every organization in the world runs into is how do you make trustworthy data so that when somebody has something like really important on the line, that you can actually trust that that data is good. A lot of people historically have answered data questions by hook or by crook, just coming up with an answer. So they'll be doing pivots in Excel, getting data from here or there and like hand roll stuff. This has happened for forever and it will continue to happen for forever. But that is not the most trustworthy way to make data. The most trustworthy is when you can have like a repeatable system, that the keyword being repeatable, that you can hit play and some set of transformations are going to happen that happen in a predictable and deterministic, hopefully, way. So the key problem to solve is writing SQL transformations, making sure to run them in the correct order, and then having output that people can actually trust. And historically, what happened is since everybody needs to do this type of thing, everybody would what? They would roll their own system to do this type of thing. They need to solve problems like create some kind of directed acyclic graph, some kind of representation of that. And then you probably don't like want to run that serially. I mean, you could, but that's like not the fastest way to do it. So then you're like doing some sort of topological sorts. You can like kind of batch stuff up together. At some point, you're going to need to probably like parse all the different SQL that you've written so that you can figure out what that DAG is going to be, what those dependencies are. And so in around 2016, DBT started to become the open source standard that allowed people to do this instead of having to roll their own. They could reach for a tool that already created it and that was available to them and that they could use. So here's what that kind of like looks like in the ecosystem of tools. People, in order to create like data pipelines, you need all your data in the same place in order to do that. Because if you have data in 2 different places, like how can you make it work together? How can you do any kind of analysis on it? It literally needs to be somehow at some point in the same system in order to do any sort of aggregations or analysis. So a common pattern that has emerged is when you have like all your data in various source systems of record, ingesting it and getting it into the same place so that you can have a query engine operate on it. And so there's a variety of products that can help you ingest data and get it into a database, a data warehouse like Snowflake or Databricks, et cetera. And one of those being Fivetran, the company I work for. And then once you have all that data from different sources into that database, then that's where DBT can come into play and allow you to then take those different tables of data and join them and do a whole series of transformations on them. We call each of those transformations will live in a single SQL file, and we call those DBT models. So if you hear me say DBT model, you can think of a SQL file. And here's like a very simple, the world's most simple DBT model. And you'll see like a little bit of funny syntax here. This is some Jinja templating. And this place where it says ref, activated users, what that is referring to is activated users is the name of a DBT model. And like I've told you before, the contents of a DBT model is just some SQL. And so what this will do is this little Jinja syntax will resolve to whatever that fully qualified database name is. The reason that I don't have that you wouldn't want a fully qualified database name here is a question you're probably asking, like, Doug, why don't you just put the name of the database table right there? Like, what is the matter with this guy? And the answer is, well, you have test systems, you have dev systems, and then you have production systems, right? Like, who wants to be in the business of like figuring out how to like swap those names? You have to be in the business of swapping those names somehow. And our solution of how to swap those names is this little bit right here. What this allows us to do also is, as people are writing the SQL, this allows us to create that dependency graph of what depends on what. All right, so now that we looked at all those like different software and all that different software in play, now that we've seen a simple DBT model, I'm going to go back to a similar visualization, which shows like in practice, people end up with like thousands of individual models, which essentially creates, a tabular set of data that then at the end can be used for business intelligence. You can use it also for like whatever ML workloads you have, et cetera, whatever your downstream consumers are, rather than them having to build from scratch all these combinations, you already have like a curated, trustworthy data set that it can then leap off from. This is like what we call like standing on the shoulders of giants, right? You don't hear any scientists say, hey, do good science by making yourself do everything from scratch. They say, hey, use the science that's come before you, or use the trusted components that you have available. So everything that I've told you so far, this all applies to the first version of DBT, which I'll call DBT 1.0, which is our current generally available supported system is DBT 1.0 as of today. But DBT 1.0 has some limits. Here's what it understands well. It really understands like what things need to be built, like what data sets need to be built, and in what order they need to be built in. And it is so awesome at that, that it's trusted organizations across the world. Like of the products and services you rely on every, would guess a huge percentage of them use DBT to help run their organization. But like I said, it has limits. Here's what DBT 1.0 cannot do. It has no idea if the syntax, if the SQL that you wrote is valid. No clue at all. It just happily takes whatever SQL that you wrote and it says, thank you. And then it ships it off to the data warehouse for the data warehouse to figure it out. So if you give it garbage, DBT will just say, hey, thank you for that garbage. And it'll just like pass it along to the next person on the chain, which is the warehouse. Which is not free. It's not free in terms of cost. It's also not free in terms of your time. If we could wave a magic wand of capabilities that the system would have in real time as you typed, the system would be able to say, is this valid, the thing that you just typed? Because if it's not, I'll just like let you know so you can make a correction and like save yourself the time of passing along. Also, DBT, it understands your table lineage. Like it'll say if you have like a customer's table at the end, it knows like the upstream tables that came from, but it has no clue that ID column that you have. It has no idea where that came from. And so if you were to make an upstream change, like let's say you want to do like a simple like rename of a column, like wouldn't you want that rename to propagate out to, I mean, I told you many people will have thousands or tens of thousands of these things. Like, do you really want to be going like hunting around every single one of those where you need to make that change? So basically all of these classes of things where you need to like understand what that SQL means, DBT has no clue. I mean, basically it can't read SQL, but it can do a very effective job of handing it off to somebody who can, which is the database. So I'm going to introduce like 3 levels of like what it would mean to like comprehend SQL. The presentation right before, we saw like a SQL query that was going to make that database and it had like that generate series function, which was just going to swamp that thing, right? Well, like I said before, if you were to run that on Postgres, that SQL will totally work because Postgres knows about generate series. But if I was to run that on like Databricks, does Databricks have that function? I mean, I don't know. I don't think so. And so you would have to send that all the way out to Databricks to know. So the first level of comprehension would be for the parser to say, hey, there's a function right here, and here's the name of that function. And to say, to at least like know what's there. And is it valid to have a function at this place in the query? So that would be like what a level 1 understanding would do. A level 2 understanding would know that this function name is valid and that like the number of arguments is valid, the data types of the argument are valid as well. And then the last level would be the syntax, like the function, the arguments, etc., and then like the data itself. So let's say in this last argument, I tried to put like February 30th. February 30th would basically be the data in this case. And that would be like kind of the third level of understanding, is to understand that February 30th is not a valid date, even on leap years. So as you know from before, DBT 1.0 knows none of those levels. But DBT 2.0 is designed to understand levels 1 and 2, everything but validating that data itself. So in DBT 2.0, which we have available and public, just not generally available, we've rewritten all of our guts, which were originally Python, and we've rewritten those in Rust. And with those, rather than all the SQL you write as just being text that it has no idea what's going on, it's something that DBT can actually comprehend and do stuff with it. So to make that possible, DBT uses another system that performs an ordinary job exceptionally well, and that is DataFusion. And you're probably curious, okay, like what components like are actually used? And the key thing that's used, because like as we saw before, DataFusion does so much. Like this slide doesn't even begin to show all the different components available in DataFusion. But this like kind of shows, if you were just to do, say, a database query, you have like the execution plan far out to the left that's actually going to be executed. And then you have like your upstream data sources. And then in your intermediate pieces, you have the logical plan is the piece that we are reusing and leveraging. And I was like clicking space to be like the next slide. And this is my last slide. And the key thing that I wanted to express to you is like when the work that we do becomes invisible and ordinary, that's actually when our work has become extraordinary, when it's so trustworthy that it's boring. That's actually when the most magic happens. Thank you.